Hi, you are back with me, right? Dr. Patamaporn from the Electrical Engineering at the Faculty of Engineering, Kasetsart University. Today, in this clip, I'm going to do Ohm's Law. Okay, Ohm's Law is a law that gives you the relationship of a voltage drop across a resistor and the current that passes through that resistor. Okay. Please note that the current with Ohm's law, the current enters the positive side of the voltage drop across R. And the formula of Ohm's law is V equal to IR, right? It's like for every electrical engineering, you have to remember this. I think the rest of your life, it will be in your head. Or I is equal to V over R. Okay, so R is of course the resistor, the resistor. V is voltage drop across that resistor, that R, and I is current passing through that resistor. Okay. Now, if we put in a voltage source into a circuit, okay, so let's say that in this case we have 3 resistors connected in series, and the value of the voltage source is 5 volt. Okay, you have R1, which will be equal to 1 k ohms, R2 equal to 4.5 k ohms, and R3 equal to 10 k ohms. Okay, so there. Well, the circuit is called closed circuit, it's complete circuit. As you can see, the current always comes out from the positive side of the voltage source. Let's call it IS. So it's a good practice for you to analyze a circuit. Is that when you have a circuit, you have to give a direction of the current flows, okay, and then with that current flow directions, you give the voltage drop and polarity of the voltage drop onto each element. So for example, in this case, IS flow out from the positive side of the voltage source. It flows passing through R1, which would result in a voltage drop, okay, potential difference at R1, right? The current would enter the positive side of the voltage drop, right, and leave on the negative side. So therefore, there's a voltage drop here that's called V1. Okay, then the current flows continue to flows, still IS, right? Pass through R2, result in a voltage drop, right? The polarity is that the current enter the positive side. Again here, IS flows, and there will be a voltage drop V3, and then it goes back, complete the circuit. Okay, if your circuit is broken, right, or sometimes we call it, you open your circuit, it means that maybe there's a wire that breaks in between somewhere, right? So in this case, R1, R2, R3, right? You have a circuit, but there's no current flow because there is a broken path and the current cannot flow through and make a complete path. So therefore, in this case, the current is equal to 0 amperes. There's no current. When there is no current, there is no voltage drop across R1, R2, or R3 because V equal to IR. So therefore, if I is equal to 0 amperes, right, no matter what R is, it will become 0 volt. Okay, so therefore, all this V1, V2, V3 will be equal to 0. in this case. Okay. Now back to the example above here. Okay. In this case, right, to find the current, well, to find the current IS, okay, the formula for Ohm's law is V over R. Well, IS, this voltage 5 volt, it actually provided, current and the voltage drop for all the R's, R1, R2, and R3, and they connected in series. So therefore, in this case, the formula for IS is Vs over R total. And R total is connected in series, so therefore the formula is R1 plus R2 plus R3. How do you know that they are connected in series? All these 4 elements, 5 volt, R1, R2, and R3. As you can see, right, from our definitions before, things are connected in series if the same current pass through them. So as you can see, IS, right, pass through R1, R2, R3, and IS. The same current. That's why we can say that all these 4 elements are connected in series. Okay, so now back to your R total. So therefore, your R total is equal to 1K plus 4.5K plus 10K, which is equal to 15.5K ohms. So using Ohm's law, IS is equal to Vs over R total. So it's 5 over 15.5K ohms, and the answer would be 0.33 milliamps. Okay. So now I'm going to show you on the experiment board that it's true. Okay, so this clip I'm going to show you the principle of Ohm's law. Okay, Ohm's law. So we have right here a simple water source, DC, okay, DC signal. Okay, I'm going to provide it with 5 volt Vs, water source here, right? So please make sure that you understand that there is a positive terminal and the negative terminal. Normally, we will use red color for the positive one and the black color for ground or the negative side of the so-called voltage drop or water source. Okay. Well, I'm going to use 2 DMM. Okay. One here is going to be acting as an ammeter. Okay, as an ammeter. So you can see that we have selected the dial at the milliamp so-called scale. The black is still at the common slot, but the red probe is now moved to where it said milliamps and microamps. Okay, so it's ready to measure current. You have to know one thing, that to measure the current has to pass through this meter to be able to read it. So therefore, that's why we say that to measure current, you have to have your meters connected in series into your circuit. This one right here is going to act as a voltmeter. Okay, so you can see that we have moved the die. I'm going to move the die to volt right here, right? The volt scale. Okay, the probe, right? The black probe is as common slot, but the red probe is here where the V sign, the V unit is. Okay, so this is to measure your voltage drop. Okay, well, when we say that voltage, it's voltage drop across R, across any element. So therefore, you have to actually, when you measure voltage, you have to put it between one point and another point, right? And that's why we say that when you measure voltage across an element, you measure it in a parallel, ways, in parallel to that element. Okay. So therefore, in our examples, we have said that R1 is equal to 1K right here, R2 is equal to 4.5K, and R3 is equal to 10K. right? And we have calculated in a previous clip that our total is equal to 15.5 k ohms. I showed you before that when we use Ohm's law, our current is equal to 0.33 milliamps. Okay, so therefore, that's why we have turned on our 5 volt already, right? So red, right, the probe, the positive of your voltage source goes connected to the red probe of the ammeter, right? So you can imagine that the current has flow out from the red, wire, go into this meter, ammeters, come out of this common, right? Common line, black line here, and then back into your R1, right? Connect to your R1, right? R1, current flow through R1, right? Come to R2, R3, right? And then it goes back into the negative side of your voltage source. That's complete your circuit as I just, lined it out for you. Okay, so we have a complete circuit. Now, using our Ohm's law, right, we have calculated that our current, total current is equal to 0.33 milliamps, which shows here, right? It shows right here 0.33. Well, it's, there is some discrepancy, okay? Not exact, but close enough. So, and the milliamps right here, this little small m here, and ampere, right? So, Ohm's law is valid. Now, if I want to use Ohm's law to measure the voltage, across each one, so V equal to IR, right? So I is 0.33 milliamps. The first one is 1K. So therefore, this voltage drop across 1K ohm should be equal to 0.33 volt. So I'm going to, let's see, I'm going to do it like this. How much do I get? There you go, 0.31. Okay. What if we do it the opposite way, right? Right now I just do red and red right here, red probe right here, and black probe right here, 0.315. If I switch the probe, right? I do it, the black's right, hold on. Black is at this point and red here. It becomes negative. Do you see that? It becomes negative, right? It means that, hey, the current actually flows the other way, the positive way. So it goes, so that means your voltage drops across this 1K. The positive is right at this point, and the negative is at this point. So therefore, you have to be careful when you're measuring, which way is positive, which way is negative with the probe. Okay. So next one, V across 4.5K. Okay. So it should be equal to 1.485 volt. So 1.56. Okay. And then last one across 10K, it should be 3.3. So about 3.1 to 0.818. Okay. So therefore, oh, it's negative. So that, oh, it's negative, right? I read it negative. So therefore, that means I have to switch it if you want a positive answer. So I switch like this. So that means that this is the correct way for Ohm's law, right? That means the current flows into this red probe on this side of the resistor. So therefore, that's that. And if you add them together, right? You add, we drop across this 1K, this R2, this R3, and the result should be close to 5 volt. Okay, thank you.